plus 1 squared times 2k, which we now have in bracket 2 raised to the power k plus 1 squared less than or equal to in bracket k plus 1 squared times 2k. That is the same thing as in bracket 2 raised to the power k plus 1 all squared less than in bracket k plus 1 squared, k squared over 2 because of the minus 2 raised to the power minus 1. Anything raised to the power minus 1 is over 2. Then if we expand we have 2 raised to the power k times 2 raised to the power k times 4 less than or equals to in bracket k plus 1 raised squared times k squared over 2. So now I have k squared over 2 squared times 4 is less than or equals to in brackets k squared plus 2k plus 1 squared times k squared over 2. Since we want to, then we now have, if we open the brackets on both sides, we have k raised to the power 4 over 2 times 4 is less than or equal to k raised to the power 4 over 2 plus 2k raised to the power 3 over 2 plus k raised to the power 2 over 2. Then multiply both sides by 2, which you now left with, you cancel both sides. We have 2 times k raised to the power 4 less than or equal to k squared in bracket k raised to the power 3 plus 2k plus 1. 2k raised to the power 2 because of the k squared is cancelling the k raised to the power 4. 2k raised to the power 2 is less than or equals to k squared plus 2k plus 1. If you now cross the equality sign, if 2k squared cross the equality sign, we now be left with k squared minus 2k minus 1 less than or equals to 0. For k squared minus 2k is less than or equals to 1. Therefore, in bracket k minus 1 squared plus in bracket minus 1 squared is less than or equals to 1. Therefore, in bracket k minus 1 raised to the power 2 is less than or equal to 1. Then we have k in bracket k minus 1 squared is less than or equal to 0. K minus 1 is equal to 0. Therefore, k is less than or equal to 1. Example: prove that in bracket 1 plus a raised to the power n is greater than 1 plus n a for n greater than or equals to 2. Solution: we are asked to prove that in bracket 1 plus a raised to the power n is greater than 1 plus na for n greater than or equals to 2. So we substitute k for n. We have in bracket 1 plus a raised to the power k is greater than 1 plus ak. Then we multiply by in bracket 1 plus a. We have in bracket 1 plus a raised to the power k times in bracket 1 plus a greater than in bracket 1 plus ak times 1 plus a. If you open the bracket, we now have multiply. We have in bracket 1 plus a raised to power k plus 1 is greater than 1 plus a k plus a squared k. Therefore, in bracket a 1 plus a raised to power k plus 1 is greater than 1 plus in bracket k plus 1 a. Then we state something as in bracket 1 plus a raised to power k plus 1 is greater than 1 plus ka plus a. Since 1 plus a k plus a squared is greater than 1 plus a k plus a, then in bracket 1 plus a raised to power k plus 1 is greater than 1 plus ka plus a. Example: prove that 2 plus 4 plus 6 plus up to 2n is equal to n in bracket n plus 1. Solution: prove that we have to prove that 2 plus 4 plus 6 up to 2n is equals to n in bracket n plus 1. Let n equals to 1. If you substitute n, we have 2 times 1 is equals to 1 in bracket 1 plus 1, which gives us 2. Then let n equals to k. We have that 2 plus 4 plus 6 up to 2k is equals to in bracket k plus 1 all over 2, which we assume to be true. Let p be equal to k plus 1, which is equals to 2 plus 4 plus 6 plus up to 2 in bracket k plus 1 is equals to in bracket k plus 1 times in bracket k plus 1 all over 2. Dividing both sides by 2, which will give us k plus 2k plus k plus 2 all over 2. If you expand, open the brackets, which will give us, we now have 2k plus in bracket k plus 1 is equals to in bracket k plus 1 all over 2 plus k plus 1. If you bring out the items that has 2 and divide by 2, this we now arrive at in bracket, which is equals to k in bracket k plus 1 plus 2 in bracket k plus 1 all over 2. So if you open the brackets, we'll be having k squared plus k plus 2k plus 2 all over 2. Example: prove that a n plus 1 equals 1 plus 1 over n a n is greater than or equals to 1. If n is equal to 0, a1 is equals to 1. For n equals to 1, a2 is equals to 1 plus 1 over 1 a1, which gives us 1 plus half, which gives us 3 over 2. For n equals to 2, a4 is equals to 1 plus 1 over 2a2, which equals to 1 plus 1 over 2 times 2, 3 over 2, which gives us 4 over